Hi, in this video I will show you how to use our ReMI-Net code to forecast a population-specific connectional brain template, in short CBT, using a single baseline time point. This work is published at the MICAI Conference 2021 and accepted. Now we will start with the installation of PyTorch and other dependencies. Next, we will see how to represent the data in order to run the code. And finally, we will test our code on a simulated data. In order to run the code on GPU, you will need to install an NVIDIA CUDA driver. From the NVIDIA CUDA archive in the link, you can select the CUDA version of your preference. Note that the code is tested on 10.1 and 10.2. In the second step, you will install PyTorch version higher than 1.6. If you will use CUDA, be sure you selected the correct PyTorch CUDA extension. For more details, check out the PyTorch website. Then, you will need to install PyTorch Geometric. Be sure its version matches with your PyTorch version. Follow the guideline in the PyTorch Geometric website. Other dependencies are NumPy, scikit-learn, SciPy, and matplotlib. If any of these packages are missing, you can simply type the following commands to install them using Python Package Manager. Finally, you can access the code via the Basiralab repository link. Before running the code, I will show you how your input data should be represented. We represent each subject with multiple views, producing a multigraph. Now, think about these multigraphs are dynamically changing over time. So, each subject is a set of multiple multigraph tensors. Now, let's tackle the longitudinal multigraph data we defined. Since our main goal is to train a model that forecasts CBTs at future time points, we are not supposed to feed the model with the next time points. So, our model takes subjects only at the baseline time point, T1. Output will be a set of population CBTs. Each represents the population center at the related time point. To run our ReMI-Net model, we recommend to use GPU for the best performance. Our code detects if CUDA is available or not for GPU computation, therefore, you can also run it on CPU. The main commands you need to use to train and test our code are the following ones. First, you need to type python train.py. This will run the training loop and it simulates a dataset if there is not any simulation dataset saved in the directory. Then, after the training is completed, you can type test.py and get the plots of the forecasted population CBTs. Also, if you want to try with another simulated dataset, you can type python dataset.py. Now, to better explain ReMI-Net execution, I will run a quick demo. First, you need to open up a terminal. Next, go to the directory of ReMI-Net code. You need to type python train.py to run the training loops. The trained models will be saved automatically for each fold. Then you will type python test.py to obtain population-specific CBTs at each time point for each left-out fold. For more details, you can check our video on our Basira Lab YouTube channel and check our code on GitHub